lab diagrams is I used the top one. It was two spans. And then I ended up using those calculations to find my moments and dealt with it that way.
Okay, so Brody is Brody. So I mean, I think you're referring not to the problem, referring to the chart that I provide as a design aid to help you to find the bending moment and shear on a continuous beam and one-way slab. Is that right?
Yeah, that's how I looked at it and dealt with the question.
Okay. I'm not sure. I don't want to say that probably this is going the not the right way. I like it to go, so I will just stop the discussion. It is not just helping me or you. I wanted to point out that my exam, not as you think, but the thing is, if I give you a copy and paste of the assignment or the example in class, to be honest, I disrespect your brain. I need to give you a little bit of a challenge in the exam to understand who is going to go beyond, a little bit beyond what I teach. So when you look at this problem here, again, this is a three span and the chart was available. You can find all the bending moment. And I ask you for only one section, to design only one section, which is at the maximum negative bending moment. Anyway, so as I said, my objective was not really happening. The discussion brought can bring a lot of frustration and anger to the class, which I don't like. Otherwise, if you get angry or frustrated, probably you will give up on my class, which is not really my intention. Okay. Anyway, let's be patient and let's look at when I mark your exam and give you some feedback and then let's see what happens. Now, there is something I want to discuss with you now before we start our real business for the class, which is the final exam. So the final exam, we have a date here, and this date is not coming from SATE. It is coordinated between different instructors at SATE, and probably some instructors already discussed with you the final exam. So our final exam for concrete will be your first exam, and that's happening on Monday, December 14. December 14, okay? So on December 14, it is a morning time exam, which means it is 8 to 12. Now, the exam is only 3 hours, and there are some of you are writing with some accommodation. So if you write with accommodation, then you get 1.5 times the time for a regular student. Now, let me ask you, would you prefer to start by 8 a.m. or prefer to start by 9 a.m.? Remember, if you start by 8 a.m., you will finish by 11. And really, I think it depends on, do you have any other exams the same day, like Monday, December 14th?
We don't have any idea of our schedule yet for exams.
No, the first exam will be the concrete one on December 14th. And then
Excuse me, Jelly.
followed.
Jelly, could you please cool down and that's not your regular tone. You're always positive. You're always cheerful. So please, can you please restore your temper again, please? And again, you're gonna pass the class. I promise you. Everyone, I promise you. All of you guys will pass the class. I promise you. Except you haven't submitted assignment and you're performing so bad from the beginning. But I can tell you almost 95% of you will pass the course, no problem. Okay, and so I want to really, my intent, my objective is to restore your temper again, all of you, not only Jelly but all of you. Okay, so please don't get so angry. It doesn't help you or help me. Okay, so Jelly, you had some input.
Yeah, it's in the civil CVT is there in the CVT team. Our first exam will be concrete 55. Concrete 55. This concrete course on December 14.
Any other exams on the same day? Because
Yeah,
I
we have
Yeah,
an afternoon one.
contracts in the afternoon.
in the afternoon. Did wait? I think it's windy, huh?
Yeah.
Yeah.
So did Wendy agree with you on specific time for the exam? Because that's kind of flexible, not like before. Before you have one time, then that's it. It is coordinated by SATE, and SATE, they already give all this power to coordinate between instructors and between you guys. And we're trying to do your best interest. So the thing is, here is the point. Here's the point. I can simply say start from 8 and I go until 11. And then if you have accommodation, you go until 12:30. You have a minimum break, and then if Wendy decides to go by noon or by 1 o'clock, sorry, so then in this case you have only 30 minutes break for your lunch, and then you do your exam. If I start by 9, I know some students, they don't like the 8 a.m. just like Gord, I guess he prefers the 9 a.m. I know it's very hard for someone to wake up like early and get ready, and maybe your brain is not functioning as it's supposed to be. So that's why I'm asking you. I could simply say 8, and 8 would make everyone safe. Because, for example, if you have some accommodation, then you finish. If we start by 8, you finish by 12:30. Can we get, or should we leave this until like another week and then we can discuss one more time? Just please, we don't have to say because it's between me and you. We can even decide it one day, or sorry, one day before the exam. Doesn't matter for me. Just a number I can put on my G2L. The exam will open or 8 or 9. But please discuss with Wendy, and this will be as soon as you settle with Wendy, then I can decide and pick my exam would be either 8 or 9. And thank you so much for the input. Henry is saying the exam is, yeah, okay. So now I know about that. So this one, Gord is preferring 9 a.m. Nicholas is asking for 8 a.m. We don't go this way. Once you figure it out with Wendy, we will just vote. And you know what? It's not big deal for me. 8 or 9, we'll see. But let's make it, let's say next week. Please try to discuss with Wendy and ask her when she planning to do her final exam.
No,
Also,
she already told
since-
us. She already told us the exam is at 2 p.m. on December 14th.
That's amazing. You guys are not, yeah. So you guys are not attending. So I ask you already. Okay. So 2 p.m. Great. So now we can simply, we have how many attendant? We have 23, and I think that's a good number to vote. So please, please, if you like to start by 8 a.m., show your hands. If you want to start by 8 a.m., show your hands. Okay, I'll give you a minute. So now we have, so far, we have only five out of 23. Anybody else want to start by 8 a.m.? We have 6. Okay, so put your hand down, please. And I think, so to be fair, please show your hands if you want to start by 9 a.m. Okay, so that's very obvious. We have 15, so it is 9 a.m. It's over. Thank you so much. The only thing I can mention right now, if you have accommodation, you start from 9, you finish in 4 hours and 30 minutes, and this will give you, will take you all the way to 1:30 and will be a kind of back-to-back. But I can tell you, for in online, I think it's not big deal. You can make a sandwich or something. You can eat it at the very last hour. So just make a preparation for that, okay? So you have short break for your for your contracts exam, and please make sure that you're well fed, and because we need some food for our brain to work. Okay. So anyway, so that was about your final exam. Let's move on to our class today. Does anyone want to add anything before we start our class today? As I said, Nick, please consider my comment about getting like a sandwich or something, okay? And I can tell you, I'm gonna tell you that's a good news than the midterm exam. Some of you, if you're not well prepared and not well trained, you may feel that the midterm one and midterm two time crush. I know some of you don't feel that way. If you are well trained and you know what you're doing, you will exactly do it in 2 hours. But anyway, anyway, the final exam will be 3 hours, and 3 hours, it means it's not like 2 hours like midterm exam, which means you'll have more time. And I can tell you, 4.5 hours, it is way, way more than you need. If you know, you will do it in way less than 4.5 hours. If you don't know, if I give you 10 days, you will not do it. Okay, so it doesn't matter. Okay, so let's move on to our class today. So our class today, we'll talk about a very important topic. I'm gonna close my midterm exam, this Black History. Nobody liked it.
Tahar, so we get 3 hours without accommodations?
Your final exam will be 3 hours without accommodation. With
Okay, sounds good.
accommodation, you get 1.5 times that, which means you get 4.5 hours.
Thank you.
No problem, sir. Okay, one more thing I want to remind you. You know, you can imagine that the student feedback questionnaire, now we are only at 50%, which means only out of 34, there is only, I think, 15 or 16 input. I don't know. I have no enforcement to you to fill it, and I know if you're angry, probably that's not in my best interest to ask you to fill the SFQ right now. But I don't mind, like, you know, say. But I am happy to see a 31 contribution to my SFQ. No matter what you say, no matter what you say, I don't mind if you say any comment, but please say something because it tells me that I cared about you for 12 weeks and I'm gonna care for you until the end of the classes, and then you don't have even 10 minutes for me to put some input into your SFQ. It feels so bad, by the way, and so frustrated. Same as your frustration for your midterm exam. Okay, so please spend some time. The deadline is tonight by midnight. Please do it if you can. Now, let's go to Hi, Muhammad. Listen. The course is so difficult course. So you know, I'm designing a design. I'm teaching you a design course, which is a high level, like, you know, thinkings and ideas. And the course by itself is challenging and tricky. Not me. I'm doing my best to make it as simple as I could. Okay. Hopefully you guys
What,
notice that
me?
I'm trying to be straightforward to the point. You know, all the classes I'm trying to make a good notes. I'm trying to be clear as much as I can. So the course is the tricky part, not my exam.
I didn't say anything. I don't know
I think
why.
you I think you are referring to
I'm sorry,
Dominic
that's
comments.
Domenico. I got confused between your pictures. My eyesight is not great even. I'm getting older, sorry. Okay, so yeah, Domenico, the midterm exam was not tricky. The course is tricky. The course is not as easy as some other courses. Our courses, by the way, so you know, I know that this kind of a side discussion. So in CVT, there are some courses which is very straightforward. Like, for example, the first year concrete, which I did the same thing. I taught you the same thing, and I bet you most of you got like A in the course. Okay, very straightforward, easy course. With a design course, and probably you already know about this one from other design courses like steel. You can imagine, it doesn't matter who's teaching you. The course by itself is so tricky, like the steel course or the concrete course. Okay, so, but you know what? It's unavoidable evil. We have to go through it and we have to do it together. I myself understand It is not easy course, and I'm trying my best to make it a little bit easier than normally it is. Okay, so now I think we need to proceed and look after our material for today. So for today, I'm going to teach you a new topic called column design. And if you remember what we've been doing so far in our class, we looked at beams, and by now, if you follow the course, you're supposed to know how to design a beam for bending and design the beam for shear, for both of them, huh? And remember, we have to do both of them. We're not designing for beam, not the shear, for bending, not shear, or for shear, not the bending. In a beam design, you have to design the beam for bending and also design the beam for shear. Also, in my class so far, you learn about how to design a one-way slab for bending and for shear as well. And we kind of, if you follow the discussion and if you really loved the classes, and there is no other option, it's either you like it or you hate it. There is nothing in between. You love it or you hate it. Okay, so if you loved what you learned in my class, congratulations, we have made a very good foundation for the remaining part of our course. Now, today I'm gonna start the column design. And typically it takes me about 3 classes to finish the column design, 3 classes. So probably it will take me Tuesday, Wednesday, and Thursday to finish the column design. And I will ensure that my assignment for column design will be published sometime this week. So then we can use our Monday class of next week to work on it and solve it. And again, you're welcome to start before even Monday and come up with questions on Monday. But really, I need to get you like a plan for what's happening on the next 3 weeks. I know that you're so stressed, and I know that you're yielding. Totally understood. And I can tell you something, a secret. I'm yielding too, so you know, okay? But I'm trying to keep myself up and still maintain the same quality of teaching through the class until we finish. And for this week, we will cover the column. Early next week, we have one class that's for solving the column assignment. And then the 2 classes of next week, we will handle and cover something called the footings. And I'm not going to teach you anything more than the column and the footing. And what does it mean? It means the last week before the exam, probably it will be kind of relief for you so you can focus on other courses and other material. Okay? For the footing, there will be no assignment. I'm going to let you talk Mahdi in a minute. Huh? So for the foundation or the footing assignment, there will not be an assignment. However, there will be like kind of a couple of questions solved for you, sent over the D2L, so you guys can use as material for the foundation design. Are you guys following? Do you have any question? I think Mahdi, you had raised your hand.
You answered my question.
Okay, thank you.
We're following.
Okay, there's no materials. Anyway,
Still following. And I'm here. I just didn't figure anybody wanted to see me eat my cookies.
I want to see you eat your cookies. I really, by the way, I wish if I could see you really face on face. Like there are some people that I met and I know personally from last year, and but this year I have some students I've never seen them before. But again, maybe some other time in our life, maybe meet somewhere, sometime, somewhere. Okay, so the plan is very clear. Probably we'll put some effort, push a little bit hard to finish column this week. Next week will be focused on foundation or footing, and then the last week before the exam, it will be kind of freestyle, ask questions. I will be available in the exam time if you need some help, things like that, huh? And so Mahdi, go ahead.
Will you have like a review package for the final exam, or is it just that we just ask questions and we go from there?
I don't know what to say. I know if I say no, some of you will be frustrated and you think you're helpless and you're left out without any help. But I'm very simple. I say focus on the notes and the example worked in the class. I know some of you will say that's not enough, but I can swear to you that even I give you, whoever is asking for more challenging exam, to me, they are asking for the exam itself. Because if I give you different question and the exam will be a little bit different, then you will need more challenging and so on and so forth. And it's kind of a chain reaction without any end. Focus for the assignment. By the way, so you know, the final exam, for sure, I'm not 100% sure, but 99% will not be cumulative, will not cover anything on the midterm 1 and midterm number 2. Because that would be crazy if I test you on the final exam on all the material taught for you from the day number 1, from good morning on day number 1 until good night on last day, then you'll go nuts. Okay? So the final exam will be focused only on footing design, column design, and shear design. I think that's my anticipation, and I think I will do that. 99% only for whatever between the midterm exam 2 and then the final exam. And I think this is for some of you who ask for the model answer for midterm number 1 and midterm number 2. I guess you're not asking right now, because simply the final exam will cover different materials.
You can just make it 100%, and instead of being 99%, I would be okay with that.
Okay, sir, I will do that. 100%. The final exam will be only about footing, column, and shear design for beams and slabs. That's it, or for beams only. Okay. So basically, it will be 3 questions: question about shear, question about column design, question about footing design. Okay, that clear? Does it make you happy? Somebody said made my day.
That's very clear and makes me very happy.
Okay, perfect. Okay, so let's move on to our topic today, and which is column. And so column, those are the vertical members in our structure. Typically, they are vertical, but some crazy architects, nowadays, what they do, they come up with crazy shapes, and some designer, they make a kind of a tilted or inclined columns. But in general, in most or 99% of our building columns, it means it's vertical element that supports slabs, beams, and girders. Columns are the main support of slabs and beams and girders. What they do is they simply sequentially they take the load from every floor, transfer the load into the column below until the very bottom column, which simply takes the load and deliver the load into the footing, and then finally the footing will take the load and spread it into the soil. Okay, so that's kind of a safe delivery. In general, the load will go from the slab to the beam, from the beam to the column, from the column to the column below, all the way until the load is delivered to the footing system or the foundation system, and then finally delivered safely to the soil. In our course here, we will simply use 3 letters. The width of the column we'll refer as H, and the length of the column is B, where always the length is more than the width. And then finally, there is a 3rd dimension, which is the height of your column. Not anything that is standing vertically, we call it column. Not everything. So columns are vertical, but not every vertical element, we call it column. Why is that? Because sometimes the section is very elongated. Which means the ratio between the length of the column and the depth and the width of the column is more than 5. And if it's more than 5, we simply don't call it column, rather than call it a wall. And in the design, there is a difference between walls and columns. And if the column is so short, so the column that's short, we don't call it column, rather than call it pedestal. So what is the criteria for pedestals? Simply the height of the column divided by the shortest dimension should be more than 3, to be called a column. If it is less than 3, it means it is a pedestal. Now, columns, like if you go back in what we taught you so far, beams and slabs. Beams or slabs are subjected to bending moment, and shear force with 0 axial force. Do you guys agree on that? Beams and slabs, they are subjected to bending moments and shear with 0 axial force. No compression, no tension. Can I get somebody to agree on this statement?
Yeah, I agree.
Yes.
Okay, thank you so much. How about columns? So columns are usually subjected to axial, so compression force in general, plus bending moment or flexure loads. Typically, column in 99%, the column will have a minimum to 0 shear, and I will discuss with you later on why they have 0 shear. Why they have 0 shear? So they are oriented vertically, and we know that we have lateral loads. We have lateral loads like wind and seismic, and some of you may wonder, how come? How come if the column is vertical and we have lateral loads like seismic and wind, how come the column will have no shear while the lateral loads like the wind and the seismic are perpendicular to the axis of the column, just like a beam? So some of you may think, no, that's not true. Big columns, they should have shear force. Okay, so some of them yes, but most of them no, and I will explain for you later on why columns they have minimum to 0 shear forces. Something before I proceed, columns, please take a note, columns are the most important element in your building, I would say. Columns are the most important critical element in your building. Why is that? Because simply their failure will simply fail your building. If you want to demolish any building, we simply demolish to fail our building. Do we demolish the beams? Do we demolish the slab, or we demolish the column? What do you think?
Demolish the column
The
right
columns.
away.
Look at any. There are so many videos on the internet about demolishing a building, whether in a very primitive way, using some machines, or sometimes use explosive. I think Japan is very advanced when it comes to demolishing the building. They can demolish a building with 0 even dust. It's very amazing. I've seen a video recently, but it has to do with the columns. Column is very important, and that's why, because column is very important. We pay attention more to their design, and we as engineers and designer tend to give them extra care and leave some extra or reserved capacity in their design. Hopefully you guys agree on this statement. Okay, let's dive deeper into the column. So please look up my screen, and you will see on my screen there are variety of different names of the column. Okay, so here are some brand new names probably you've never heard of. So you can see on my screen there is elevation and cross section of some columns, and one of the things that we can differentiate between one column to the other column about the ties. I know ties is brand new, like, we used to call it a stirrup. We used to call it a stirrup in a beam. So in a beam, we call it stirrups. In columns, we call it tie. And I always make the mistake, always, so you guys can be ready. When I teach you, I always, by mistake, say stirrup while I refer to tie. So what is tie? Please look up my screen, and this is the tie. And again, it looks like a stirrup, but it's not a stirrup. It is something called a tie. Okay. So when it comes to classification of column, this column here called the tied column, and we can do the ties just like a stirrup, one every given spacing, or sometimes we make a continuous wound around or spiral around the vertical rebar. And in this case, we call this column spiral column. So this column is called spiral column, and this column is called the tight column. And we will have more discussion in our class about spiral columns and tight column later on. But both columns, both of them, we call them reinforced concrete columns. So it's a mainly concrete, and we add some reinforcement, which is the vertical bars, those vertical bars in addition to the ties. However, there are some columns that people sometimes they use, which is not really reinforced concrete. So this one on the right here, probably you heard about it, called the composite column, called the composite. And this is a combination between Tahir and Corwin. You can see how beautiful this combination is, huh? So it's a steel member, it's a W section, just like your steel course. And simply what we do is we encapsulate this steel member into a casing of concrete, okay? And in reality, it is more complicated than this. It's not just a W section and then we box out the concrete around it. Not really. There should be a good connection between the concrete and steel so they can work as composite. Otherwise, to be honest, if this is the case, the concrete will be just a protection for your steel. Typically, this is used like in high-rise building, and high-rise building, it's kind of very complicated, by the way, so you know. It is not only about loads. In the past, people they use concrete to make high-rise building, but concrete is not as strong as steel. So what happened is they decided to go for steel because simply the bigger your section, that's a problem, huh? If you end up in the basement with column that's 1 meter by 1 meter, that's a serious problem because simply you are eating up the usable area in your floor plan. So to use a more floor plan, people they start to use steel. But I can tell you, September 11, they changed the whole thing. So right now, I would say they are start to change this whole thing from steel into concrete because of the fire. Really, I think if you really dig deep about, there are so many documentary about how World Trade Center failed in September 11, and the engineers, they said it's not because of the hit by the aircraft, but because of the fire, because of the explosion, because of the fire. So the steel simply melts. If you have a fire event, the steel melts. And again, it's a very, very big topic. You know, do we build with the steel? Do we build with concrete? Again, that's a big topic, which is outside our discussion. But for this discussion here, I want to point out that we can make concrete our column this way. Those are called reinforced concrete columns. And the one on the right called composite, which is not really part of the scope of this course. Okay, now, as part of this course, there is another classification of columns based on their slenderness ratio. Okay, you guys know that there are columns very slender, like very slim or very thin, and there are some columns they are chubby and big. Okay, so very important. Probably you already heard the same discussion in steel. So in steel, you heard about buckling. Did you? Any confirmation?
Yes.
Did you hear by now about something called the buckling? So buckling
Yes.
is a phenomena that simply happens to all the members that they under compression. So any member that's under compression, it will buckle. Okay. So really the buckling is factor of how slim or how chubby or how fat your member is in plain English. Okay. The buckling is completely factor of how slender is your member. And that's why in my course here, you will learn about something called short column and something called long or cylinder column. Okay. So really the point is buckling. Should we ignore the buckling or can we ignore the buckling because my column is not cylinder, or our column is so slim, then we must take the buckling into effect. So I need to prepare you before we start the discussion, which will happen probably tomorrow, not today, which is simply, are we going to do the same thing as steel? So in concrete design, Is it as difficult as steel, like for buckling? I can tell you it is not. So is way simpler than steel. Steel, because of the members are very slim, so buckling is an issue, and that's why the design of steel members are different from concrete members when it comes to buckling. Really, at this point of time, all I want to say is columns can be classified also not according to the ties or spiral, not according to concrete composite, not according to the shape, which is square and circular. There is another classification of column based on their slenderness ratio. If the column is not cylinder, we call it short column. And in this case, the buckling effect can be neglected. And if the column is cylinder or long column, then in this case, we must consider buckling to design this column. In our course here, we only cover only short columns. We cover only short columns. And please don't think that we are teaching you very little. No, we are teaching you so much. And so if you want to design a long column, it takes you probably another 2 hours of the class to learn about long columns. So whatever you learn here with us in my class, it will give you about 90% of what you need to design a long column, okay? Now, few things I'm gonna, talk about this slide because it's very interesting, and then we can take a break. Now, really in this slide, which is very important, typically it's part of your final exam. So if you want to take a note, I'm talking about the anatomy of the column. So the column has 3 different elements, and those elements, they're supposed to be very clear from the picture on the top left, which is the vertical bars, the vertical reinforcement, the ties, and then finally our concrete core. We have 3 different elements: the vertical bars, the ties, and concrete core. Now, every one of those elements are very important to the survival of the column. Just imagine, can we build our column without vertical bars? Ask yourself yes or no. Can we do that?
Absolutely not.
Thank you so much. And then, can we build a column with vertical and concrete but without ties? Yes or no?
Absolutely not.
Thank you. Restoring your spirit, Jelly, huh? And then third is, can we make our column from vertical bar and ties only without concrete? Absolutely no. Okay. And the reason why Jelly or other students say absolutely no is because the slide on the screen. I'm going to go ahead and show you what are the benefits of every element in the anatomy of my column that contributes to the strength of my column. And you will see every one of those is absolutely necessary for the survival of our column. Number 1, which is, to be honest, you will be surprised if I tell you that transverse reinforcement are the most important one, I guess. I know they are kind of equally important, but I don't know. I prefer to always start from the ties. And ties, not stirrup, so I will use, and please, if I make the mistake and I change this wording inside my next 5 hours, please correct me. It is ties, and we don't call them stirrups. So what is the function, or what are the functions of ties or spirals in your column? Here are the function. Number 1, because those ties, they are oriented perpendicular to the axis of your column, simply they will increase the shear resistance of your column. Shear resistance of your column. I know I said columns, they have minimum to 0 shear applied force, but when you add some ties, simply those will increase the shear capacity of your column, same as they did with the beam. When we add stirrups to the beam, what they do is they bump up the shear capacity of the beam. Number 2, they hold bars in place during construction. Very important. You can imagine, what if you build a column that has no ties and then you know what happens when we build concrete, huh? We fill concrete from the top, we shake our concrete to finish our column. Then if you have no ties, the vertical bars will go everywhere, and you will never get their actual intended location. If you have some experience, you will understand what I mean. The ties, they hold the rebar, the vertical rebar in place during pouring concrete. Otherwise, they will go everywhere. Number three, what they do is they increase the compressive strength of your concrete, because simply those are kind of, think about them as rings, huh? They are kind of confining the core of the concrete, increasing the compressive capacity of your concrete by itself. Okay. Number four, which is very important, please mark it on your notes. This is very, very important, this one here. Okay. This one is very important, and we will have more discussion about this one later on in our classes. This simply provides lateral restraint of bar under compression. Probably I can give you a little bit of idea before we start. Think about it this way: even if we're not worried about concrete, the rebar go anywhere during construction, and we're able to maintain the rebar in place, but without ties, huh? So think about it. Let's say we came up with some invention that simply maintain the vertical bars in place while we're pouring concrete. But let me ask you, when we apply axial force compression on our column, the vertical rebar will be under tension, compression, or what?
Compression.
Under compression. And you guys know that those vertical bars, since they are under compression, they will tend to buckle. Yes or no?
Yes.
Yes.
Yes, they will do that. And think about it, what if I have no ties? Guess what? The vertical bars will buckle on the full length, and the column will be so weak, and the column will fail at a very, very low load level. Premature failure, they call it, because of the buckling, not of the column, the buckling of the vertical bars. Let's be clear, not the buckling of the entire column, rather than buckling of those vertical rebar.
Tahir,
Mhm.
it from the photo you're showing, it looks like the ties would only prevent it from buckling like one way. So are we always assuming that it's always going to buckle towards the outside and not the inside? If you get what I'm saying.
The inside, there is a concrete core, and there is no way for the rebar to go. So to the outside, there is air, and there is a very little cover, and simply the bar will buckle to the outside, because simply there is a very little cover, like 3 centimeter or 4 centimeter of concrete, and simply it will go this way, if you agree.
Yeah, I never thought about the concrete on the inside. That makes sense.
Okay, so I mean, with the existence of ties, guess what? Still the vertical rebar can buckle, but really it doesn't buckle on the full length. It buckles only on the distance in between the ties. Let me show you here. So really, if your column wants, not the column, sorry, I'm not referring about buckling of the column. I'm referring buckling of the vertical bars. If you provide ties, guess what? Yes, they can buckle, but they can buckle only on this length. If you don't provide ties, they can buckle on the full length, and you know the length is for the buckling. The more buckling length, it means it will take less load, if you agree. Okay, so we have couple of items to go, which is the vertical bars. So let me show you what is the importance of those vertical bars. Number one, they are oriented vertically, so then they will contribute to the load carrying capacity. So you will see shortly after the break that some of the load will be supported by the concrete core, and some of the load will be supported by those vertical bars. So they contribute to the vertical load capacity. Number two, they increase the bending capacity. Remember, if we remove those vertical bars, your column will have very little bending or flexure capacity, if you agree. Okay. Let's move on to concrete core. So the concrete core, it provides or add to the concrete compressive capacity, and it also adds to the shear capacity of your column. To be honest, I really appreciate those ties. They make the magic. If you make your column without the ties, simply your column is not gonna survive at all. Okay, so with this, I would like to break for 10 minutes. I will see you at 11:08, please. Thank you.